عليكم يا شباب. إن شاء الله تكونوا جميعا الأهل والأصدقاء والمعارف بخير، والعملية هانت الحمد لله. الامتحانات تحددت وربنا يوفقكم بإذن الله. ده recording بتاع drugs introduced during calendar year 2019. وأنصحكم إن كنتوا قبل ما going through هذا recording إنه كنتوا تكونوا راجعتوا الريكوردينج السابقة لل part 2 part 3 of the last lecture أو the final lecture اللي هم متعلقين بدراسة سنة 17 و 18. اوكي، بعد كده the parts 1 and 2 were already recorded. وصلنا الدراسة 2019. هنجد إن إحنا زي الدراسة السابقة خلال هذه الفترة، فنجد إن إحنا عندنا في سنة 2019 إنه الكانسر والإميونولوجيكس هم أكتر مجموعة موجودة، يليها الأنتي انفكتيفز كما هو مبين بصورة أفضل في هذه السلايد نمبر 5. okay. نجد إن Global Introductions في 2019 مقارنة بالprevious years من سنة 1993 نجد إنه الكونتريبيوشن بتاع البيولوجيكس 10 من التوتال اللي هم كذا 40، وبالتالي فيها ولكن still أقل من السنة اللي فاتت أو اللي قبلها، ولكن في نفس الوقت ترفلكتس إن إحنا عندنا باستمرار more biologic introduction، خاصة إذا أخذنا إنه العدد 10 doesn't include البروتينز اللي هي up to 40 amino acid، و it doesn't include also doesn't include also the oligonucleotides, whether it's single stranded or double stranded, whether type that were introduced, they are introduced or approved by CDER rather than CBER. If we look into this slide showing the biologics approved in 2019, we'll find that we have most of these are the number of biologics that were introduced by the FDA. There are similar biologics introduced by other regulatory agencies, mainly the EMA and PMDA, that is the Japanese agency. We'll observe that most of them are either MABs or antibody drug conjugates containing a MAB attached to a payload, in addition to a fusion protein. We have already covered one fusion protein already in previous years. Please refer to it. You'll observe that one of the maps is termed the nanobody, which means we'll get to that into what does it mean practically when we get to the specific slide for this map. If we look to the classification of these new introductions by modality and its indication for each of these compounds, we'll find that still the majority of these compounds are small of these introductions are small molecules. However, the introduction by of other biologics is still there with a good percentage, including the biologics, including the fusion protein, one fusion protein, 3 ADCs, 4 MAPs, and a nanobody, which is a monocular, which is still a map. We'll get to that. What do we mean by a nanobody? And then other compounds that are there. If we look to these other compounds, we'll find that we have about the oligonucleotides. We have 2 oligonucleotides. Oligonucleotide approval, which is divided 50-50 between the 2 modalities. One is the antisense, and the other one is small interfering or short interfering RNA oligonucleotide. We already covered what the difference, which one is the double-stranded, which one is a single-stranded, the role of these compounds as regard to modulation of the messenger RNA, and why what they are used for in previous compound. Here we have 2 more of this compound. We'll have to differentiate the INN name, which will tell us if this is a siRNA or antisense oligonucleotide. Which one is the single strand and which one is the double stranded from the stem included or approved by the IN naming international INN naming system set by the WHO working group. Another presentation showing the number of biologics relative to the number of total introductions by the FDA. Similar type of ratio is present in both the EMA and PMDE. Well, the previous slides are mainly concerned with the CDR approval, that's Center for Drug Evaluation and Research of the FDA. Let me remind you again that this includes as new molecular entities both the oligonucleotides and also small relatively small proteins up to 40 amino acids are included in the CDR approvals, though they are biologics. Okay, and now this slide actually showed what's approved by the CBER. CBER is responsible for the approval of all other biologics. For example, pegylated recombinant factor 8, and also gene products. Okay, and it's also responsible for cell therapy. Then it's responsible for cell therapy, gene therapy, and a high molecular weight polypeptides. In addition to that, it's also responsible for vaccines, of all types of vaccines. And however, we are not going to discuss this because we already covered the production of CAR-Ts in other courses during the study in previous years and this year. Okay, then this slide shows the abbreviations used during this presentation. Please go through it as you proceed to individual drugs. Whatever abbreviation you'll have to understand appropriately what does it stand for and the significance of this abbreviation. In addition to that, you are provided in textbook with the two pages of abbreviations used and acronyms used during the study of this course. Please refer to it easy for more rational comprehension of the subject matter of each slide. This four slides, 12, 13, 14, and 15, give you an outline of the CDR approvals. When we come to the CPR approval by the end of this, when we finish this CDR approval and their equivalent introduced by EMA and PMDA, will get to the CBR approval and talk about it a little bit. Okay. Well, you may that the review process, it is the standard review process because already the API, the active pharmaceutical ingredients, is already named, but this is another indication for this already known API. Well, this is the nanobody. We talked about it amongst the biologics. As you can see, this factor, one Wellbrand factor, which plays a role in the role of platelets in the thrombosis formation cascade, which I asked you already to study it very well when you studied that in biochemistry, in clinical biochemistry. So go back to it and see how each and every step of this thrombus formation cascade is materialized in clinical setting. When we say nanobody, it relates to the molecular weight of the and the size of this molecule. So this is only a fraction. It is not a whole antibody. Okay, most of the mAbs that we studied already are whole antibody. Now this is a fraction and part of the heavy chain containing our 260, exactly 259 nano acids. Two fractions of this are connected via three amino acids to each other, and this is inhibits the Wellbrand factor, which leads to the interaction between this factor and the platelets, thereby reducing both the mediated platelet degradation by this factor and also the platelet composition. Accordingly, it is produced to one type of thrombocytopenic events, which is acquired thrombocytopenic purpura, as shown in A, or abbreviated as ATTP. Well, nothing much to say about this compound, which is a antiparasitic agents with the first ATC code level P, and used for the management of fasciola infection, because fasciola is not very much spread, or the incidence of which in developed countries is not that much as relative to developing and underdeveloped countries. So it is given an O status of an status situation, and there is nothing new about its design. It's very much, it is just a small variation or little variation in the structure relative to this benzimidazole derivative, which we already covered, and most of them are well known since over 30 or 40 years ago. Well, this drug is a steroid. When you see a steroidal structure, you immediately think of sex hormones and anti-steroidal anti-inflammatory agents and this type. Well, the action and use of this steroid derivative is rather different. It is used in the management for the management of postpartum depression via being a positive modulator of the GABA A receptor. You may recall that one of a steroid derivative is used by injection as an anesthetic. So this compound is another rather unusual utilization of one of the steroids, which is related to progesterone, being a pregnine derivative, and it acts by being a positive modulator of the drug. When we think about the drug receptor interaction, we have interaction at the active site, which is called the orthosteric agonist, and then we can have action at the allosteric site, which is remote from the orthosteric or the original active site of the drug. However, interaction of small molecules or a ligand with the allosteric site leads to some conformational perturbation, so as that would lead to modulating the action at the allosteric, at the orthosteric or the original active site, as shown here with. Okay, and let me remind you that, of course, the ATC is bending, so accordingly, if we can still predict the action, the first level ATC code of this steroid, it wouldn't be under H hormones. It wouldn't be also under sex hormones or the sub-level of the H first therapeutic level. Then you can try to figure out what would be the first ATC code of this compound. Right. Two molecules which are used to manage narcolepsy or excessive sleeping due to narcolepsy or respiratory sleep apnea, excessive sleepiness due to alcohol, though via two different mechanisms. This compound is a phenethylamine. Okay. Phenethylamine, and it's a prodrug, as you would expect. It's the carbamate derivative of this compound. You should exercise also how would a prodrug is metabolized into the active phenethylamine or the derivative of this propylamine, actually derivative, and also a phenethylamine derivative. As well as another compound which is a lisant, and it acts as H3 receptor antagonist or inverse agonists. Okay, we were exposed to H1 receptor, the classical H1 histamine 1 receptor, H2 receptor for the management of this pepsia. And of course, I'm not sure if you have covered the compounds that act on the H3 receptor, but you should have covered where the H3 receptors are located, mainly inside the body, and accordingly their utilization. Okay, for both of these compounds, since they are used to manage excessive narcolepsy, then they are undergo the N class of the first class label. Here, this figure illustrates the concept between a full agonist, or difference between a full agonist, a partial agonist, a neutral antagonist, or an inverse agonist of the compound. All right. Well, next small molecule is a drug that's used to manage insomnia. Its ATC code is still pending, but you can find you can at least suggest the first level of its ATC codes based on its indication. Now, this compound is, I don't know if you have already were exposed to orexin modulators, but orexin, just a reminder, orexin is a neuropeptide signaling molecule playing a role in wakefulness, blocking of the binding of the wake-promoting neuropeptides orexin A and orexin B to the receptors or 1 and 2 is thought to suppress wake drive. Accordingly, blocking these receptors would result in antagonizing the wakeful awakening signals, and accordingly leads to overcome the insomnia symptom. Now, this is a small molecule used for the management of relapsing forms of MS, that's multiple sclerosis. This compound is related to a naturally occurring compound or designed after a naturally occurring compound from extracted or obtained from certain fungi. And this compound, and it is related to a one that's already marketed at more than one actually. This compound is the IN name is C-pony-mod. It's a modulator like other sphingosine modulators, sphingosine 1-phosphate receptor modulator already marketed, such as fingolimod and C-pony-mod, or those which are in clinic and other mods too. So these modulators modulate this sphingosine 1-phosphate receptor, and leading to the less migration of lymphocytes into the central system and affecting demyelinization of the central nervous system, which is manifested as multiple sclerosis. A conventional monoclonal antibody used for the management of osteoporosis. Maybe you have to remind yourself of another monoclonal antibody, denosumab, which is a rank ligand modulator used for the same indication. You'll have to remind yourself of the balance between osteoclast and osteoblast osteoblast formation, the balance between the two, and how this rank plays a role in this type of indication. Okay, well, what are the advantages of it? This is the only difference is it through a different mechanism. Instead of rank L, then we have the sclerotin. Is this compound monoclonal antibody acts as a monoclonal and as sclerotin. Now here we have 16 NEBs, tyrosine kinases. Okay, you'll have to remind yourself what is the role of the kinase in general, the process of phosphorylation in the phosphorylation. Now we have actually in the therapeutic armamentarium around tens actually of TNEBs. They differ from each other. They have this inhibitor end at their name, the name. And we can differentiate actually between different types of TNEBs regarding to what is involved. So the proton kinase modulator, proton tyrosine kinase, some act via BTK, and they have this ending at infex-trick, and so on and so forth. So they are accordingly, most of them are used for the management of cancer, and accordingly they have different indication for different types of cancer. How this is produced, actually cancers can produce more than one of these factors. It depends actually on the efficacy in clinical setting. Accordingly, this is what actually determines the type of cancer for which they are used. Some of them they involve a certain mutation or a fusion positive solid tumors, such as the fusion positive solid track that the BTK is involved, and actually they can exemplify precision medicine where there is a companion diagnostic for this type of utilization, and we have to check the patient for the particular parameter by the use of a regulatory approved diagnostic. Plaque psoriasis, first level is L, then we can put it at the proper classification for this compound. It is a typical whole body, whole map. The heavy chains, light chains, you can figure out, of course, the the SS bonding sites and disulfide linkage and the glycosylation. What we didn't cover before, and we are not going to cover, you will know that if we are talking about the glycosylation, then they are designated, the position of which is designated by either the CH2 and N, the amino acid, and then there is a certain number, which we didn't cover in literature in the INN nomenclature, just a little bit. Now, if we have also to to show that the site of if the glycosylation includes fucosylation because of its importance in the activity of the MAB, where you usually have to define what kind of fucosylation is concerned. All right. Now this drug tafamidis was already approved for another indication several years ago, and now it is approved for a new indication, and accordingly, intellectual property wise, it is a breakthrough drug, and start with the intellectual a new period of intellectual property this way. Why it is used in the it's used to stabilize transthyretin. What's transthyretin? It's a protein which is produced in the liver, and then it produces a tetramer. And this tetramer, if it is degraded to the monomer, then if this monomer is misfolded, then it forms an amyloid fibril, which leads to several complications, including cardiomyopathy. So accordingly, to stabilize this process of transformation from the tetramer, stabilizes the tetramer and prevents its formation of monomer, which could misfold into the amyloid part. Okay, we had already covered in previous lectures lyseps, inhibitor of PI phosphoinositide 3 kinase, and accordingly used for certain types of cancer. But what kind of breast cancer? It will have to be tested. Patients will have to be tested to be sure that they are hormone receptor HR positive and HR2 negative by means of a companion diagnostic. Now here we have two ADCs. The payload is the same Vidotin. This is monomethyl auristatin E, which is a mitotic inhibitor, and accordingly used in different types of cancer, depending, of course, on the clinical evidence. One of them is directed towards CD49, and the otherwise is directed towards Nectin-4. Okay. Another antibody drug conjugate with the payload is a topoisomerase 1 inhibitor, which is again anti-mitotic compound, and which is based on shell-less mollusk, which is about 200 folds more active than vanplastin, which is a plant-based natural product, also topoisomerase module 1 inhibitor. For HER2 positive breast cancer, as proved by a companion diagnostic. Now here we have two melanocortin receptor agonists used for two different indications. Now, how these agonists differ from melanocortin, then we'll find that they contain D amino acid modification. One is actually a hepta, and one is a 13 amino acid peptide, cyclic peptide actually. And the first one, the primalontide, is used for hypoactive sexual disorder. And the second one, the 13 cyclic amino acid peptide, cyclic 13 membered amino acid cyclic peptide, is used for the development of erythropoietic protoporphyria. Now, this is a drug for the management of, indicated for the treatment or management of multiple myeloma, which is a bone marrow cancer, by a mechanism that's completely different from other bone marrow multiple myeloma drugs, which include some monoclonal antibodies, which includes also thalidomide derivatives, the famous thalidomide derivatives that are used for the management of multiple myeloma. But this compound involves the use of the binding to exportin 1, and thus blocking the transport of several proteins involved in cancer cell growth from the cell nucleus to the cytoplasm, which ultimately arrests the cell cycle and leads to apoptosis. It is the first drug of this mechanism of action. Now here we have a combo anti-infective drug, which consists of the antibiotic imibinem. Imibinem are of the class of the carbapinem derivative, which they don't have another thiazole ring as the penicillins, and that's why they are called carbapinem. Imibinem, but imibinem being a very good antibiotic, nevertheless it is degraded in the kidney by the renal dehydropeptidase. Accordingly, this combination contains cilastatin, which is a renal dehydropeptidase inhibitor, just guard against the degradation of imibinem. Let me tell you also that some of the carbapinem, such as meropenem in here, they don't need a dehydropeptidase in their formulation. In addition to that, this is being the imibinem is a carbapinem. It is a beta-lactamase antibiotic. It is a beta-lactam antibiotics subject to the degradation by beta-lactamase. Accordingly, this contains a beta-lactam, a novel beta-lactamase inhibitor, which is not as of the same category as the beta-lactamase, the inhibitors that you already covered and which are shown in the next slide. You covered already clavulanic acid, sulbactam, so you are familiar with tazobactam probably, but now the recent mono beta-lactamase inhibitor, they do not have to be beta-lactams themselves, as you can see in here. One involves a boronic acid derivative, and second one is containing a N sulfate ring, as the functional group, and these two compounds are very closely related, avibactam and the bactam, which was covered in the which was used in the combination for the shown in the previous slide. Now, due to the development of resistance to chemotherapeutic agent, so for example, this compound, which is the multi-drug resistant TB, and this compound to handle microorganisms which become resistant to cephalosporin. Now, this of the type of antibiotics is provided by QIDP status, regulatory status, to encourage the introduction of new antibiotics to guard against antibiotic resistance, which is a gradually increasing problem in the management of chemotherapeutic agents. This is to manage infections, because the QIDP, which are resistant to cephalosporins, and QIDP is qualified infectious disease product, which is the program provided by the SRE to encourage by the FDA to encourage the introduction of new antibiotics. This compound for multi-drug resistant TB pretonamide, and its IN name is honors the Pretoria, which is in South Africa, to example charity to honor the charity organization in South Africa that helped production of this compound, or the introduction of this compound under an initiative which is called Tropical NTDs, neglected tropical drugs. The disease, okay, so all right. Now here are three actually drugs for the management of multi-PV due to the failure of the conventional anti-TB compound to be to manage TB or multi-drug resistant TB. And accordingly, we have three. These are new to the relative entrant to armamentarium, in addition to pretonamide, which is shown in the previous slide. This is another antibiotic that first to be used in humans. Derivatives of pleromodulin antibacterial compounds are used in animals, but the first human use for it, which is a natural product inspired as it is obtained from certain fungi. And it inhibits the FS50S subunit of the ribosome, with the same mechanism. It checks the same mechanism of action as that with phenol group, and is used for the management of community-acquired bacterial pneumonia. Nothing much to say for this simple compound. It is a ferric maltol derivative having this structure, and it is used as a source of ferric iron for an iron deficiency anemia. A newcomer with the androgen receptor inhibitors, this compound having this structure, it is related to the other previous, it is actually not related to structurally, not related much for to other androgen receptor modulators of this class, except for this phenylnitrile carrying in an electronegative group in here. So it is present in this majority, which is present also in here, and here we have a pyridine nucleus instead of the phenyl rings and the other three compounds. Well, these are used in the management of prostate cancer, and we have to differentiate between the use of synthetic steroids, finasteride, a modified steroid, which is not used for prostate cancer, rather it is used for benign prostate hyperplasia. So don't confuse this compound, they are not interchangeable, of course. Now this slide shows actually the two radiopharmaceuticals which are used for diagnostic purposes. Both are used for PET imaging, positive emission tomography. Fluorodopa is radioactive. Both of them are radioactive diagnostic. The gallium detartrate is used for localization of somatostatin receptor positive neuroendocrine tumors, with the ligand carrying this radionucleotide and the somatostatin analog with this slide. The other one, both of them, and the other one is a F18 instead of the gallium-68, which is again against PET for PET imaging of the full diagnosis of for the diagnosis of Parkinsonism syndrome. Okay. Now this gives you an idea in the practical hospital setting. This is a generator, a primitive generator, which was used at technetium-99M way back when it was discovered, way back in the previous century, and some modern generators which can be used for the generation of gallium-68 from its precursor. Now, talking about contrast agent diagnostics, an ultrasound contrast agent is used, polymer type A, which is hydroxyethyl cellulose, consists of hydroxyethyl cellulose, glycerine, and purified water provided in 2 syringes, which are mixed prior to the administration. What it is used to diagnose, it should be to assess the fallopian tube patency in women with known or suspected infertility. Okay, so this was introduced 2019. Okay, what about how were there other diagnostics that were used before this? Yes, there was. They are less expensive. For example, etherized oil, which is a poppy seed oil containing a double bond, which adds iodine containing the etherized oil, which is used to buy as also not as ultrasound contrast agent, but rather as an X-ray contrast agent, being an iodinated derivative. Is pending, but you can consider it sort of a diagnostic to localize the stain, to localize internal limiting membrane of the eye, and it is used in retinal surgery. This estrafilin, the adenosine derivative, and adenosine receptor antagonist, used in the management of episodes of Parkinsonism disease. Okay, you know that the people suffering from Parkinsonism, sometimes whatever they are using, such as levodopa, carbidopa, or combination thereof, they become sort of useless, and they experience what we call the off episodes symptoms. This is where this compound, escorpheline, is used for. Now, this drug is a transporter. And particularly, it is an anti-porter for NHE, standing for sodium proton exchange 3 anti-porter, which it is responsible for the interchange of sodium with water in the reabsorption steps of in the intestine and also on the kidney. Accordingly, when we have IBS, inflammatory bowel syndrome or disease, then we have, it is either two types, either with associated or predominantly constipating or predominantly diarrhea. In this case, it will be very useful because it will increase the amount of the water and accordingly making the feces fluidy, and accordingly it is very much useful for IBS with predominantly constipating inflammatory bowel disease. All right. Well, this compound is a retinoid. It's actually a fourth generation retinoic acid receptor agonist, gamma receptor agonist. I remind you that we are starting from vitamin A. The oxidized vitamin A is the first retinol agonist, the retinoic acid agonist that's ever used, and it is used for actionable gags. Then we start proceeding to second generation, introduction of aromatic ring structure, and then third generation, and this is the fourth generation of this class of compound. Of course, it is used topically at a very low concentration. Now, this is the drug which is used for wet age-related macular degeneration, a serious disease for vision, disease ophthalmic, is for the elderly, particularly for the may lead to blindness, and it actually results from excessive proliferation and angiogenesis nearby the macula. Here we come that's why we have to say wet age-related macular degeneration, and it is introduced. There are other drugs which were previously introduced. It is a it is a vascular VEGF factor inhibitor. It is a single chain fraction antibody, molecular weight of about 26 kilo Dalton. That's why we cannot classify it as a nano body, which is in the range of 10 to 15 kilodaltons only. However, it is still a map. It doesn't have heavy light chains and all the conventional structure. So I just want you to be available of the fact that the fact that there are different antibodies, they don't necessarily comply with the conventional 2 heavy chains to light chains and so on. And these fractions, and so whether single domain or otherwise, single chain, still they are capable of acting as antibodies and used therapeutically for this purpose. Here we have 2 drugs working by 2 different mechanisms. In the lasmiditan, which is closely related to the triptans commonly used for the management of migraine, except that it is rather more specific serotonin 5-HT1F receptor agonist, thus devoid from the side effects generated by other subtypes, mainly the B and D receptors of other triptans. The other one is a modulator of calcitonin gene-related peptide. It antagonizes the gene-related peptide. We already discussed this is the first small molecules to modulate this gene-related peptide. We already discussed 3 maps, one acting on CGRP receptor, and the other MAG are antagonistic to the protein itself. We covered it during the last, part 2 of this presentation. Now, this is sort of a reminder about the drugs used in the management of migraine. Now, this compound of the last slide, the first small molecule, that it is non-peptide small molecule, that modulates the CGRP antagonist, small molecule, the non-peptide antagonist, and the monoclonal antibodies, whether they act on the receptor itself or the molecule itself. I'm sure that these 2 are approved. I'm not that sure of the regulatory status of this one. Now, this combination is used for the management of cystic fibrosis. It consists of 2 CFTR correctors and a CFTR cystic fibrosis transmembrane receptor and ACFTR potentiator. Okay. Why we use 2 correctors? In order to broaden the spectrum of this combination, so as to cause the most common gene mutation that causes cystic fibrosis. There is the very common gene mutation, which consists of the F5 or 8, I think, deletions, which need correction. But there are other mutations other than the F5 or 8 deletions. So to broaden this, we use 2 correctors for this purpose. This is the 2 combination combo of 2018 introduction, 1 corrector and 1 potentiator. Now, this is a fusion protein consisting of 2 components, the modified extracellular domain of the human actin receptor type 2, this one, linked to a human IgG1 fraction domain with calculated molecular mass of approximately that much. So this is another variant of the monoclonal antibodies on the fusion proteins, and having two components from different types of factor induced in the management of the anemia in beta thalassemia, being a erythroid maturation agent. Now, this is a drug that's used in management of certain vaso-occlusive crisis in painful complications of SCD, that's sickle cell disease, when obstruction of the blood flow is affected by the sickle cell, and it acted that induced that by blocking P-selectin, which is present on the surface of the epithelium of the vessels, as well as on the platelets, and results in this vasoconstriction crisis. Now, here's another drug for sickle cell disease. Now, the previous one used to manage the vaso-occlusive crisis. Now, this is compound. The other hand, the process of hemolysis that may take place along as a manifestation of the sickle cell disease by increasing the affinity of oxygen to hemoglobin S polymerization. By inhibiting this process, thus contributing to decreasing of the hemolytic factors of indices in sickle cell disease. Now, this is an siRNA, small interfering or short interfering or silencing RNA based drug. It's an oligonucleotide, double stranded, as we can see it here, and then modified as we'll see in the next slide. It is directed towards the aminolevulinic acid synthase. The siRNA directed this to this aminolevulinic acid synthase. What's the relation between aminolevulinic acid synthase and porphyria? Well, porphyria results in the genetic disease, and results from the buildup of toxic porphyrin derivatives. This is porphyrin derivative, for which aminolevulinic acid is a precursor. And if we stop that, when these toxic porphyrin derivatives result in the manifestations in the known as a hepatic porphyria. Now, in the next slide, then we can see actually the detailed structure of this compound. Now, because it is double-stranded, and there is a sense strand and anti-sense strand. Now, the sense strand will be here is attached to a ligand, what's called ligand 96, which is a tridentate tridentate galactosamine residues attached through are attached to this covalently bonded to these strands to these strands. Why? Because this enables delivery of this siRNA into hepatocytes. Otherwise, it wouldn't work. Now this is golodexin, or SEN, which it signifies we have to differentiate between this and SI-N, which is a small interfering double-stranded. This is a single-stranded, have a morpholino derivative, and a 6-member morpholino derivative instead of the 5-member ribofluorescein present in the regular RNA and DNA. And also it is attached, this 6-member link is attached by a covalent non-bonded phosphoramidate group. Now, this single-strand compound bind with the other strand in the gene, complementary strand, but it switches off the process of expression of the appropriate dystrophin. And when this happened with skipping of the 52 exon 52 skipping compound, this leads to the production of more dystrophin and accordingly used for the management of the gene muscular dystrophy. Now, this small molecule is used to manage partial seizures. Though it say that the unknown and mechanism of unknown, but it's well established, at least in vitro, that it is a voltage-gated sodium channel blocker, voltage-gated expression, and it is also a positive allosteric modulator of GABA ion channel. Another small molecules used for to manage or indicated for the management of schizophrenia, and being an atypical amino psychotic acid. We have in your undergraduate you cover different types, starting from haloperidol. You then treated to 5-HT modulators in this situation, and also the first atypical antipsychotic compound. Well, this showed the CBER approval, which is responsible for the regulatory approval or rejection or whatever it is, regulatory aspects of biologics, which will include the vaccines, live attenuated, modified vaccinia, live attenuated trivalent vaccine, which we are not going to discuss. And then we have a gene therapy and a pegylated recombinant factor A for the management of hemophilia A. We will look very briefly into the following. Now, this is a pegylated recombinant factor 8 derivative. This is a biologic produced by the same technology for recombinant procedure, and it is further pegylated. You know how to pegylate compounds, why we pegylate compounds. We covered this in the first 3 lectures of the course at the beginning before this social distancing problem. Well, it is used for management of hemophilia A. Then we have to activate the compound by depegylation and inside the body, and then it is used as it performs its normal function and accordingly used for the management of hemophilia. Therapy, from the name, it contains the zero gene, and then parovec, it contains a viral vector, which is the AAV based and responding for SMN gene therapy for spinal muscular atrophy. Okay. At this stage, you'll just know how to deduce from the INNA the kind of vector that's arranged and that it is the gene therapy. It carries a price list of 2.15. It's a single treatment administration price with 2.125 million per treatment, which makes it the most. Figures show the relation between different SARS viruses and the relation of the early SARS drug of the winter 2002 as they relate to COVID-19. They are very similar. Both are having the attachment receptor, the angiotensin converting enzyme 2, which is shared by both the bats and humans. Spike protein proteining takes place by the same cellular proteases, and according to the neutralization efficiency by SARS convalescent serum, the plasma is high and moderate in COVID-19. Okay, this is a representation of the life cycle of COVID-19 virus and possible repurposing of other drugs for as they relate to the replication cycle. Chloroquine, hydroxychloroquine, favipiravir, remdesivir. These are used in rheumatic arthritis and arthritis. Favipiravir is a polymerase modulator used in Japan. Remdesivir is a protein technology produced. This may remind you of sofosbuvir, but same protein technology. So in addition to chloroquine and hydroxychloroquine, we have the other antiretrovirals, ribavirin, other remdesivir, favipiravir, and all these compounds are used in hospital setting. They are not approved. They are approved under compassionate use for as an emergency compassionate use drugs. Then the corticosteroids, dexamethasone, and related compounds, which are of course used along with many drugs, like in multiple myeloma, like in management of rheumatic arthritis, etc. Being anti-inflammatory because of the anti-inflammatory storm, then anti-cytokine or immunomodulatory agents such as 6 modulator. These maps are also being investigated. A TNIB used for the rheumatic arthritis is being also investigated for this purpose. And then finally, the immunoglobulin from convalescent plasma.